Welcome to Faith, Fiction, and Folklore, or as we like to call it, the Try F podcast, where we try not to F the podcast stuff, which we have done once tonight already. It's fantastic.
It was my fault.
Off to a great start. We're like an hour and 45 minutes late. It's amazing.
No, YouTube said I deleted it forever, so it's gone.
Oh, yeah, so there's no evidence of how incompetent we are. So are we up now? Can you see on the YouTube channel if we're up now?
Hold on,
It says we're up.
Yeah.
I gotta refresh.
You gotta refresh? Okay.
I'm refreshing.
Because it says
Yep,
we're
it says
streaming
we're
on
live.
OBS.
Yeah, we're up.
Okay, great. Well, in that case, tonight we're talking about, is the Earth flat or round? Cody's got some videos pulled up, and we're going to look at them, we're going to react to them, and we're going to see what we think about them. And so with all that said, my name is Gary Varner. I write for Mind Matters News. Cody, how are you this evening?
I'm fantastic, man. I just hope we don't mess this up again because it's been painful so far.
It has. It's all right, though. We will figure it out. These are growing pains. So,
Oh, yeah.
so Mr. Trevor, how are you?
I like growing pains.
You're already too tall.
Well, that's why I like growing pain.
Okay.
true.
I'm ready for this, whatever we're talking about.
Whatever we're talking about. Have you not been paying attention?
No, I haven't.
Gosh, dang it, Trevor. Okay, well, are we ready to start watching this video? Trevor, you're just going to follow along as best you can.
Yeah, let's do it. I've got it pulled up on my phone now, so if you don't have it streamed through OBS, I can watch it through
Sweet.
there.
Oh, that's right. We got to do screen share, don't we? I forgot all about that. This is the exact same mistake I made last time. Hold on a minute. But I know how to fix it now.
My cat keeps trying to drink my coffee.
Oh, yeah?
That's funny.
Oh, goodness. So we're going to screen one, share, back to full screen, which puts us back where we are. Hey, I did it. I know what I'm doing
Nice.
now. Sweet. Okay. So, all right. I'm going to switch us over here. And is everybody good? Nope. I can't
Yeah, we're
do
good.
that. All right.
There it goes. We're rocking and rolling.
Sweet.
Houston, we have a problem.
What you're seeing here is a mirage.
When you see no
You
curve,
have to come way up on the
but you know
volume.
you should.
Yeah, we can't hear it.
Still.
Who you
all
gonna
right.
call?
Hold on a minute.
Globe Busters. Ah,
I can hear it
Hello,
on a
everyone.
live stream. But
Jaronism here again. This
on
time,
Zoom.
answering those who said I wasn't
about
bringing any
now?
evidence. So I decided I'd just
better.
debunk the minute physics 10 reasons we know the Earth is flat. So here goes. 10 reasons, 10 debunked. Click the link to watch those first, or follow me. Number 10.
I'd go up
The
a
other
little
planets
more.
are round. Telescopes
Sorry?
are made with convex lenses,
Go up
folks.
just a little more.
Before them, all anyone
think
saw
I'm
in the
maxed
sky
out
were
on
stars
everything.
and wandering
Let's see.
stars. That was
Okay.
it. Egypt worshipped the lunar
What
disk,
now?
and the ancients worshipped the solar disk. Here's my photo of the lunar disk. Not a sphere. One side always faces us. No hot spot because it's a disk. Number 9. Time zones. No edge jokes,
What about now?
just edge understanding. Here you can see the sun circles atop us. And look at that.
Maybe.
It makes a great little timepiece, doesn't it? And the sun,
Go up.
the moon, and time all go clockwise. Number 8. The Coriolis effect.
Sorry, say that again. I can't hear you over the video. It's really loud on my end.
Yeah, go up a little bit.
Okay.
We will
Maxed
kill
out.
2 birds with 1 stone when we get to the stars. Here's a quick clip about number 7.
Triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again, and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles.
So, we can do the test here. You can watch me on Google Earth, but let me explain it.
This is going really fast. Do we need to start
Yeah,
over?
it is.
'Cause we're on like 3.
Yeah, I mean, if you missed the first 2, then yeah.
Yeah, let's try this
Watch
again.
those
I mean,
first.
they're kind
or
of quick.
follow-
Little.
All right, yeah. So maybe we need to just stop and go after this point by point. All right. So let's see. What's our 4 minutes in? Okay.
Follow me. Number 10. The other planets are round. Telescopes are made with convex lenses, folks. Before them, all anyone saw in the sky were stars and wandering stars. That was it. Egypt.
All right. That's stupid. Like that right there is stupid. What does
Right.
what does a telescope have to do with anything? Like I can see that the sun and the moon are round with my eyeballs.
Well, what he's saying, like, so these are points that are saying these are this is from the globe perspective. This is why we think the Earth is round. So it's
Right.
like the other planets are round. We can see them with a telescope. But so if you take like a square truck headlight
Uh-huh.
a mile away, it's going to look round, right?
Yeah.
Okay, so that's
Yeah.
all he's saying.
Okay. Got it.
Egypt worshiped the lunar disk, and the ancients worshiped the solar disk. Here's my photo of the lunar disk. Not a sphere. One side always faces us. No hot spot because it's a disk. Number 9. Time zones. No edge jokes, just edge understanding. Here you can see the sun circles atop us, and look at that. It makes a great little timepiece, doesn't it? And the sun, the moon, and time all go clockwise. Number 8, the Coriolis
Okay,
effect.
okay.
We will kill two birds with one stone.
I'm confused. So how does that prove one theory or the other?
I don't
Like,
think he's. I don't
Am I
think he's trying.
misunderstanding something? Like, is it not necessarily trying to... Is it trying to prove that the Earth is flat, or is it just saying that, like, either theory works?
I think he's just talking about it, getting it set up.
Their argument points from the globe perspective, saying this is why we know the Earth is round.
Yeah,
And
but
he's
it's
going.
like time zones. I've never understood, like...
I still don't understand time zones, man. They don't make any sense to me at all.
Yeah, I just don't know how it proves anything one way or the other. Like, I figured if the Earth is flat or round, there'd be time zones.
Yeah. Probably.
Yeah, I just don't... It seems like it's a wash.
Yeah, maybe. There's 10. We'll keep watching.
Okay.
When we get to the stars, here's a quick clip about number 7.
Triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again, and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles.
So, we can do the test here. You can watch me on Google Earth, but let me explain it first. This would prove absolutely nothing anyway. The test he gives assumes that we're on a globe. Is the walker going straight, or is he going on one of your latitude-longitude lines? Here's the thing. The reasons it doesn't work is because to make it work, you have to start at the pole, where all the lines meet. So yeah, guess what? You walk down any one of those lines, then walk across. You can catch any line that you want back to the top of the pole. It's called cheating. It's called misleading. It's a lie. I won't continue to bore you with this one. Simply go get Google Earth. Play with it yourself. It's impossible.
I have no idea what am I
Okay,
missing?
so he's saying he can make an equidistant triangle on a globe by drawing lines on Google Earth. That's the I don't know. That's his proof. I don't know.
I maybe I'm dumb. Maybe I'm missing something, but I'm kind of like, well, what are you trying to say? Like,
Well, because this video that he's watching is a glober's perspective, saying this is why we know the Earth is a globe.
okay.
Okay, and the guy reviewing the video is just saying this is a fallacy because you can do that with this Google Earth. You can make any equidistant shape because the lines all go to the same spot.
Yeah, I mean,
guess.
I figured you'd be able to make a...
I'm sure I butchered that.
Well, I mean, I figured you'd be able to make a shape no matter what the object is anyway. I'm kind of... I guess I'm lost. I'm like...
He's trying to prove curvature, like, because you can make a triangle on a globe. So he's like trying to use that to prove curvature.
Okay.
But you can take that map and do that any way you want.
Yeah, you would be able to do that
Right.
anywhere because, well, the way I understood it, when the Greeks were testing to see if there was a curvature of the Earth, they didn't do anything like
Aristophanes.
this. I'm sorry?
Aristophanes.
It might have been it. I don't know. But the way I understood the experiment was they basically measured the moon from one position to another position and kind of measured the bend of the angle of the shadow or whatever. Like, moon shadows here, and then the moon shadows over here at another place on the planet, and judging on the angles and stuff, they were able to calculate the diameter of the Earth, and the story is they got within so many thousands of miles, of accuracy compared to how we measure the Earth today, just basically by measuring the angle of the shadows of, of the moon in one position and the moon in another position, or maybe it was the sun. So they used the bend of the sun or the moon in relation to how the shadow was hitting it to kind of estimate the diameter. So whatever triangulation this is, it's like I don't think that's how they proved it in the first place. I thought they were using triangulation methods with the sun and the moon to guess in the beginning. I'm probably butchering that too.
I don't know.
But I'm like, this doesn't...
Angles aren't my expertise.
Well, I suck at math and I barely understand the concept. I just know that at one point they used the sun and the moon and the shadows to measure the diameter. That's all I could tell you.
Yeah.
So, do we want to move on?
Yeah, let's keep moving.
Okay.
The way it works is by starting at the top of the globe, which is cheating. All you're doing is taking one of the lines down to the equator across, and one of the lines back up. You can just take a look at these 3 right angles right here. I think those angles look pretty acute to me when you turn the triangle over. The sun, as we've explained, sets out of your field of view on the horizon, gets smaller as it goes away from you. He mentions the ability to use the sun to get the circumference of the Earth, which works if the sun is 93 million miles away, but also works if the sun is 3,000 miles up and 32 miles across. Number 5, stars change going...
Okay, so that's actually an inference to what we were talking about. So,
Yeah.
Let's go back.
I've actually got one of the later videos has a more in-depth explanation of this. I think
Okay.
we'll enjoy.
Well, I want to listen to what he says here again.
He mentions the ability to use the sun to get the circumference of the Earth, which works if the sun is 93 million miles away, but also works if the sun is 3,000 miles up and 32 miles across.
So he's saying that basically there's more than one math equation to explain what we see.
Yeah.
Like the numbers would be, like there's more than one way to get the phenomenon. Like there's, so if it's many thousands of miles away, it could work. But if it's, so much closer, it could work as well. But if assuming the sun's smaller. Okay. That makes sense. So there's more than one scenario where that could play out. But that's fair. Okay.
Number 5, stars change going north or south. Why, yes they do. Why don't we explain why that happens? Here are the stars. You all know about Polaris, right? It is in the north. So you can take your position here on our star chart, look up north, see where Polaris is, and watch which way these stars rotate. We all know that the stars rotate counterclockwise when looking at the north, and so you get the confusion of people saying, well, what about the south? They rotate the other ways. Well, let's watch. You can see that they lift to the upper right, going up that wall, counterclockwise. So let's keep following that. Remember that, up this wall, up the wall. Keep rotating to the right, up the wall, up the wall. We keep going a little bit more, up the wall, up the wall. We're getting towards the south. They go up the wall. Look at that. Now they go clockwise. That's all it is. There is no southern pole star. They're all rotating the same direction. It's like a big tunnel rotating above us. And if you think about it, that is the same thing for the Coriolis effect. They tell you that in the northern hemisphere, tornadoes go one way, southern hemisphere, tornadoes go another. This is your explanation. Depends on which way you look. Everything rotates the same way, but there's always the eye of the observer. Magellan circumnavigated the Earth. I'm sure many of you have before. No edge jokes, just understanding the edge. Make a circle going west and you'll end up exactly where you started. Number 3, the horizon. We've all seen the Globetrotters swear by this one. But here's the tip. When the boat gets out of your line of view and starts to drop behind the curve, get a telescope and guess what? It'll reappear because globe edges hate telescopes. Then he drew a picture and he said if flat Earth was true, that you'd see Chicago from Michigan. Superior mirages, anyone? Guess they're superior indeed. Then he drew the Rockies behind his buildings and said if Earth was flat, we'd be able to see those too. Because everyone knows that smog, fog, exhaust, heat, mist, dew, and dirt don't exist. See here? You can barely see the 4th ledge. Number 2, lunar eclipse. Who knows what they're doing here? One thing is for...
So I'm not seeing like reasons to think that the Earth is flat. I'm seeing like basically there's competing hypotheses.
Well, there's a guy. It's a guy saying one of their claims is there's a guy. He's like, oh, well, if the Earth was flat, you could see it from Chicago to whatever he said. And it's
well, which is dumb.
as he showed, as he showed, it's because of the density of the atmosphere.
Yeah.
It's like how much stuff is in the air.
Yeah.
So I think that's all he's
a
saying.
really dumb person who said that.
Yeah.
I mean, even if the Earth was flat, I wouldn't expect that.
Right.
You know, okay. Anyway.
Sure, shadows cannot contain color. If you had a blue aura around you, would your shadow turn blue? No. Second, many reports exist where the sun and moon were both above the horizon and a lunar eclipse took place. That cannot happen unless they're messing with the moon. The eclipse is simply not what you think it is. Last but not least, number 1, photographic evidence. Oh, seriously? Oh, okay. We'll take an image, check to see if it's a composite, which most are. Check others, look for anomalies, and then take a deep breath because, ladies and gentlemen, you just realized that the Earth is flat. Take a look at some of these and you'll see that they're using stamp-on clouds. They're identical to other places on the images. All you got to do is do your homework on this one.
All right, I gotta.
There you have
complain.
it, ladies and gentlemen.
It's like, it's so obvious. The answers are right in front of you. It's like, no, dude, I just see a bunch of rectangles over clouds. I have no idea what you're referring to.
Well, if you zoom in and look at those, I mean, you can go through it. You're supposed to do your own research. It's what this video is for.
Well, I don't know. I don't know enough to even know what questions to ask. He's telling me like composite.
The blue marble image is iconic. Like it's.
Mm-hmm.
And if you go through and look at it, there's like doubles in the clouds and stuff like this, because it was, there's parts of it that are copy and pasted.
So
it was a contrived image.
Okay, so let me see if I understand this. So the image of the Earth, they're saying is a blue marble, and they copy and pasted digitally clouds and land masses over it.
Yeah.
Okay. Well, I'd never heard that before, and he's saying that you can see where, like, the overlap of the photos. That's what those rectangles are?
Yeah.
Okay. I wouldn't even
Like
know how to test.
the doubled clouds. It's just, there's software that finds that stuff.
Well, I know, but my thought is, okay, you're talking about. Let's see, do you know when that picture came out? I mean, obviously, be after '69. Was it 70 or something like that?
70s.
I don't. To be blunt, I don't know if our composite tech was that good. It might have been, but I don't know if it would have been.
From what I hear, they were photoshopping stuff like in the 1800s.
Oh, I don't know about that.
Like with razor blades and stuff. People have been at it for a long time.
Well, I think the first photograph was 1837. There's a picture of a guy doing, getting his shoes shined. It's like a shadow. It's a silhouette. I don't know if they were photoshopping stuff because, you'd have to like disregard pretty much all of history and come up with a completely different, which maybe we've been lied to about everything, but but the traditional theory is you couldn't do something like that because those pictures, it took hours of like leaving the film or whatever they were using for film exposed in the sun for forever and a day, and then you would still get shadowed, blurred vision. Wasn't great, those exposures. So I don't know how you'd be photoshopping things in the 1800s. I think photoshopping...
With razor blades, after a picture's already done, they can...
Well, I don't even think they had film that way.
Or darken.
Like, I don't think film even worked that way back then. Like, I would have to look at... But you've seen those movies with, like, the old cameras where they have, like, the big wooden frame, and they'd slide it into the camera thing like an accordion, and then they'd have big flash powder bang. I don't know if you could use razor blades to edit stuff back then with that kind of tech. So...
It was black powder they used?
Flash powder. That's all I know.
Yeah,
So... They were using flash powder to expose the film. Like they had to keep the film in the dark, and then they had to let the sun soak it for a while, and then they had the flash powder to burn the image onto the filament or whatever it is that they were using.
Yeah.
I don't know the terms.
Yeah.
It could be, because the feds obviously hide tech way longer before it's ever out exposed to the public. So maybe they had Photoshop, years before.
Obviously it's not a program, but
yeah.
I think there's been people manipulating pictures for a very long time. That's
Well,
all I'm saying.
to do what they're claiming with the blue marble thing, I mean, you would need some kind of computer. Is the bottom
Well, it's
line.
back
You would have
maybe.
to have some sort of computer compositing. I don't know. You couldn't do that with razor blades, so you would need some kind
Well,
of computer
no, it was
graphics.
the 70s. I mean, they had computers.
Yeah, I'm trying to remember because the first computer composited image that I am aware of, and I actually just was editing a video on this like literally last night. The first computer composite image I think was the movie Westworld. It's a dude riding on a horse, and I don't remember when the original Westworld came out. But that's like supposedly the first computer composite image. And you would need something like that to create whatever he's saying is happening.
Mm-hmm.
So, I mean, we can Google that. Trevor, you want to Google that for me, please?
What's the blue marble thing going?
That's the name of the picture.
Oh, the Earth and the clouds and whatnot.
Yeah.
Yeah.
Okay.
Yeah, I'm not getting my
What am I
browser.
googling?
What year did
There
Westworld
it
come
is.
out? The original Westworld. From what I understand, and maybe I've got my facts wrong, but from what I understand, that's the first time, in public anyway, a computer was used to composite an image. Could be wrong, but that's what
doing
I
it live.
think it was. We're doing it live.
1973.
So 73. So when did the blue marble come out? This picture of the Earth come out.
I was trying to use Yandex and it was not cooperating with me.
So we'll flip out of this for a minute. So
1972.
72. So I mean, it's feasible. Maybe they did it, way back when. So you got 72, 73. It's close. Timeline's close.
Yeah.
Could be.
Well, there's that. Do you want to hit that next video?
Yeah, we're gonna punch
is
it
there,
real
is there
hard.
any other points? Did we get through all of them? I guess so, because this is just his outro logo, isn't it?
There might be a couple we missed, but
Globe Busters. That's funny.
yeah.
Okay.
That's a show on Sunday they do. It's pretty good.
I like that. We should look into them.
That's punny. Okay. Let's go to the next one then, yeah.
I got
So,
you, punny.
Let me switch back to our original shot while I switch things over. If I can get this thing to go. There it goes. Good night. All right. So somebody else talk while I set this up.
He's talking. He's talking.
I can send you the link for the Globebusters show tomorrow because they do it every Sunday.
That would be good. Sure.
It's pretty fun. They just kind of go over the technicalities of everything,
Okay.
the nerdy stuff,
Yeah. No, I think we have to get into the nerdy stuff, and since I suck at math, it's going to be like a time-intensive endeavor.
Yeah,
So,
for sure.
Nerds in geometry.
it's all perspective. Okay. So the next one is it's all perspective. The channel is DITRH. What is it? Dearth.
Down in the rabbit hole.
Down the rabbit hole. Oh, down the rabbit hole. Okay.
Down
Okay.
in. Way down.
So this
In
is
the rabbit hole.
explaining.
This is Eric White, or not Eric. Must have been thinking about Eric Dubé. This is Dave Weiss.
Okay, Dave Wise. Okay, and they are explaining how the sun sets on a flat Earth.
Yep.
And okay, the mechanics of it. All right, so here we go. And of course, YouTube's got to add its censorship. Wikipedia. The flat Earth is an archaic and scientifically disproven conception of Earth's shape. Just in case you were wondering, we don't agree with this, and we got to tell you because you're too stupid to come up with your own opinion. So suck on our opinion, plebs. Anyway.
Where do I set?
So you gotta pay close attention.
Nights.
Gotta act. Line of sight. Let's read this. The cloud remains at a constant height.
Okay, so I guess it's a good point because the podcast, we do need to explain this. So what we are looking at is a man looking up. The cloud remains at a constant height. And then we got a picture of a dude looking up at a cloud, and then we got this line that says the horizon.
Yep. So that's his eye level is the horizon, right?
Yeah.
Perspective.
Okay. So watch what the cloud does.
Okay. Well, maybe I'm getting ahead of myself, but I gotta like challenge this idea here. So the clouds remain at a constant height. I don't think we actually know that. Is he claiming that the cloud
Just
remains
watch
at a
the
constant
video.
height, or is he like saying like that's like our basic assumption, like in the math equation, the cloud stays the same, and if that's the case, this is what you're going to see, or how am I
I
articulating?
mean, clouds form differently at different elevations, right?
Yeah, and they move
So
up
that
and down
cloud-
based on
that
wind
cloud
currents and
changed
stuff.
elevation.
Yeah,
If that
well,
cloud changed elevation, it would come apart in theory. So just go for the sake of the video. Just go with it.
okay. I don't know if I agree with that, but okay. All right, we'll go with it.
Cloud looks lower, it's further away.
Okay, yeah, I'm sorry. Maybe I need to get up to the mic because I can't hear you guys, so I'm assuming the viewer can't hear it either. So it says, as the cloud moves in the distance, from the point of view of the observer, the cloud looks to be descending. So I see what it's saying. Okay, so now I understand what's going on. So the clouds, it's not really saying that clouds always stay at the same distance. What it's saying is, as a cloud travels away from you, presumably it's staying at the same distance, but from the point of view of the person in question, it looks like the cloud is sinking into the horizon.
Yes.
Okay. All right.
Line, his eyes is almost level with the horizon. So the cloud is now on the horizon.
Right. So he's seeing in a straight line, and it looks like it's on the horizon. Yeah.
Even though we know if the cloud was actually on the horizon, it would come apart or whatever.
Yeah, it would change and probably dissipate or something.
Yeah.
Okay, got it. This is very climactic music for a weather lesson.
Yeah, it's like,
Like, guys, the Rohirrim hasn't arrived. We're talking about clouds. Calm down. Okay, so what we're looking at is we see that the line is not level from the point of view of the second observer.
Yep.
So for those on the podcast, we've now got another dude. He's looking up as well, but he's standing in the opposite direction of dude number one. The horizon line is still in the same place.
So now dude number one is looking at a cloud above dude number two's head.
Yeah.
But in theory, well, I mean, he wouldn't be able to see him because he's on the ground, but
Yeah.
because you're looking through density. Oh, anyways, you can keep going.
Yeah.
The line is not level, it slopes down to a great height.
Can I say that again, Cody?
So the line from the first observer to the cloud above the second observer should be straight, but it descends at a great rate.
Okay, I'm getting stupid again. I'm having a hard time conceptualizing the issue. I followed part one easily enough. So,
The second observer is just giving you a placeholder for where the cloud is
okay.
from the point of view of the first observer.
Okay, so looking at this picture, we still got the 90-degree angle from dude number one, and the cloud is directly above dude number two's head.
Yep.
And the horizon's in the same place. So I don't know if that illuminates anything for anyone or not, but
well, let's just say dude number one is Gary, and he's watching the cloud. And dude number two is Cody, and he's watching Gary.
Okay, so the dude's not looking up at the cloud. He's looking at observer number 1.
Is that right?
I don't think it mentions what the second observer is doing yet. I think we're talking ahead of ourselves.
Okay.
Oh.
All right.
Maybe Trevor's right. I can't see.
Okay. You know what I'm going to do? I'm going to turn this music off, and we're just going to watch the diagram and narrate it, because this music is like really distracting. So.
Yeah, that
Can't
music
hear the
is.
music.
You can't hear the
is
music?
Like,
No, it's like splotchy.
yeah, I can barely hear the music, but I can hear the music over.
You guys
anything
must be
else.
picking up the audio from my. Am I not sharing my volume? Hang on a minute.
No, it's been volume coming through your mic.
Oh my gosh. Why doesn't it share the stupid computer volume? Like, I put share
funny.
screen for a reason, guys. What are you doing?
Well, it only shares your screen. It doesn't share your audio.
Oh, it has the option
well.
to share computer audio. Okay.
So you're saying that it might share the audio randomly and will be deafened?
I'm thinking there's demons in the computer switching stuff around. Because I have had the option to share. Let's see here. We can share at a time, multiple participants. It doesn't matter. The video's music is stupid anyway, so we're just going to narrate this video, and I'll try to figure it out while you guys talk about it afterwards. So, okay, here we go. All right, so nothing is happening. We've got the sun has entered the scene. The sun moves directly above the cloud. Then it moves away from the cloud. And so, arguably, the sun's like, dude number 1 can't see as much of the sun because the cloud's blocking it. Then the sun moves out of the frame. Now we've got...
Wait, what? Back up. I think...
Okay.
No. I think that's trying to illustrate that the sun is disappearing behind the horizon.
Okay, so it crosses the viewer's cloud horizon.
Cloud horizon. Yeah.
So we got the sun moving past the cloud. And as it does so, this is what is really happening. The sun is being blocked by the cloud.
No, the horizon.
But the horizon's down here at ground level.
Right.
So this is the dude's
But the
point of
cloud, we know
view.
the sun isn't actually at the ground level.
Right, okay, so the sun's not at the ground level, right.
So it's disappearing behind the horizon. But not the second guy's horizon yet.
So what
Is
you're
that
saying
right?
is dude number 1 is getting the sunset.
Yeah.
I think it's just talking about the cloud blocking the sun.
Hey,
I don't
could
think we're
be.
talking about sunsets.
I've never seen a cloud completely block a sun.
I mean,
Not
I
a little
have,
one like that.
but... Okay.
If it's a rainy day, the clouds
Yeah.
will block the sun.
Yeah, if it's a particularly rainy day or something like that, I mean, it
Yeah.
blocks the sun. So
But not a little one like that.
no. I'm assuming it's just that one little one's supposed to be just to demonstrate the point.
Right.
Well, I mean, if you look at it from a dude number 2's perspective, that cloud is massive.
Yeah, I'm having a hard time following anyway, but we'll
It's
keep
perspective, yeah.
Yeah,
It's all
keep
about
going. So,
perspective.
bottom line is, though, for whatever reason, from dude number 1's perspective, the sun is starting to no longer be seen.
Yeah.
Because the cloud is blocking it. And I don't think we've addressed what the dude number 2 is looking at yet.
Dude number 2 is just under where the cloud is actually at.
Yeah. Okay, so the sun disappears behind the cloud. Or at least this dude's POV. From the observer 1's point of view, the sun disappears.
Yep.
Now, but this is what he perceives. Okay, so we are talking about the sunset. So from his perspective, the sun is dipping behind the cloud as it goes below the horizon.
Sure. Yeah.
Okay.
But it's not actually dropping in elevation.
Yeah, so it's
See, this is just a light. Watch this real close.
yeah.
It's beautiful, isn't it?
I'm not. I gotta be honest. Maybe I'm being.
Go back and
biased,
rewatch that
but
part.
I'm not. I'm not seeing it. So it dips. So we got level line, same level line. I am so lost. So, audience, what we're looking at is we got a shot of a hand and a sun dipping below a line of sight in one frame. And then in the next frame, we have a sun moving across a line that's
It's
been
level.
tied from one end, from left to
It's
right.
two different perspectives of the same level line. So the level line on the left is the camera is right at eye level of the line.
Correct. So this is like if you were
So
looking straight.
as it moves further away, it looks like it's dropping, but it's not, obviously.
Yeah. Yeah, that's fine. So it drops below the line of sight.
So basically, go back a little bit. Okay, pause it right there.
Okay.
So the first showing with the sun going away from you, that's like a sunset basically, which is the sunset on the right. That's basically what you're seeing. And then where it says same level line, that would be like a sunrise basically.
No, it's
But
all a
it's-
sunset.
Well, yeah, but on the same level line, it's like the sun is headed towards you, right?
No, it's just showing it from a different perspective so you know what it's doing.
I got you. Okay.
But is this another one of those videos that's just showing that both scenarios are plausible? Because that's
No, it's
kind of
just showing you perspective. Like, because the whole argument is, man, that they took the measurements that they got from your vision. So like our eyes are balls, right? So we see a certain way,
right.
right? And they applied that math to what they're saying is the shape of the Earth. And so when you tell someone what their perspective actually does, like what their eyes actually do in a different context, it kind of blows it apart.
I got to be honest. Maybe I'm just stupid, but I'm having a really hard time tracking with this because I'm sitting here. What I was always told was like this phenomena, the sunset, is basically the result of the curvature of the Earth. You know, and okay, well, from what I'm looking at, it just seems like what the guy's saying is that you can get the same phenomena with a flat Earth scenario.
Yes.
And I'm like, okay, well, you've got two competing hypotheses. How do you know which one is true and which one is false? Because I'm not seeing anything that would make the round Earth impossible. I'm just seeing stuff that makes a flat Earth possible. Does that make sense? I'm not seeing one idea destroying another, so to speak. I'm just seeing, okay, well, this is another way to look at it. Which is fair. I mean, I'm not saying they're wrong. I'm just like, okay, but why do you think one over the other?
It's all about perspective.
Yeah, but it's just what.
It's just showing you different perspectives. So,
yeah, but why would a flat Earth be more likely than a round Earth?
Because I'm not spinning.
Okay, what?
But your fan is spinning.
Within the context of what we've seen, why is one scenario more likely than the other? Is my point. Like I'm trying to understand why you would prefer the flat Earth scenario over a round Earth scenario, given this phenomena. Because I feel like both are equally probable, and yeah.
Yeah, I mean it's a plethora of information.
yeah, I guess I'm just. I understand. It sounds like what's happening is they're just trying to show, like the two videos we've seen, they're just trying to show that it's not impossible for the Earth to be flat given what we've observed. But
Sure.
and I'm like, okay, fine, maybe it's not impossible, but why do you think one over the other?
For me, it's just, it's like I don't feel like I'm spinning, so I'm going to look for information like this to, see what other perspectives are out there.
But why would you think you'd
And-
be feeling like you were spinning if the Earth is round?
Let's get into that on the next video.
Okay, all right, maybe the next video gets into it.
It does.
Is there anything else? Okay, no. So that's the outro.
I don't think so.
We'll switch over to that one. Okay, you guys, you and Trevor go back and forth for a minute while I try to fix this audio issue.
Okay.
And then once I've either decided it's impossible or have got it fixed, we'll go on to video number 3.
Okay. Trevor, are you staying warm?
I'm trying to.
Good. Good. Well, tomorrow the sun will come back around on the old great circle.
Circle of life.
Warmed up again.
Well, it's not that the sun will come back around. It's that we're spinning around the sun.
Oh. So you're a
Right.
heliocentric centrist?
Well, that's just my guesstimation.
You a sun worshiper?
I do not worship Ra. It's
You're
Ra,
saying he's
right?
more important than Earth, right? He's at the center.
No.
That's what you said. Heliocentrism, right? Helio in the middle. Ra, it's in the middle of the galaxy thing.
Oh, I was just trying to remember which god is the sun god. I don't even remember.
No, it's
which
Ra.
one.
Yeah, you're right.
Is it Ra? Okay.
Yeah. Yeah.
I try not to do any idol worshiping.
Well, I mean, when you put
Unless-
Ra at the center of your worldview, you get it.
Unless it's copy.
Yeah. You understand that? The heliocentric thing? It's like sun worship.
Actually, no, I don't know anything about heliocentric.
So whenever you put the sun at the center of your cosmology, your worldview, like how you see the world, you're putting the sun at the center and you're moving around it. That's sun worship. So this whole flat earth thing is basically like, I'm not going to worship the sun. The earth is in the middle. I'm a geocentrist.
Oh, I see. Okay. I get it now.
Yeah.
So if I say that we're spinning, like our whole solar system is spinning around the sun, that's the, what word was it you used?
Heliocentrism?
Heliocentrism. That's a long word.
Yeah.
And then the opposite of that would be flat Earth,
Geocentrism.
which is geo. So which god would that be?
Because if the sun is, well, I mean, I think this is what the biblical cosmology is. I think the Hebrew book says it. I mean,
Oh, okay.
so, but yeah, the sun, if the sun's local, it's like, 3,000 miles or it could be 30 miles. I don't know, dude. But it's going around us. It's like, it lines up with the Bible. It says this, the sun and the moon and the stars were put there for signs and seasons.
Right.
So like the sun goes around every season and grows your food.
All right.
So that puts it back in its place in the Bible.
Sweet.
Oh.
I think I've got this craziness fixed. I think.
Nice.
So, perspective. Get rid of that. All right, so we aren't spinning. Deal with it. Flat Earth, Sun, Moon, and the Zodiac. I'm assuming Zodiac.
Yeah, that's an app by Dave Weiss. It's pretty cool. You should get it if you feel inclined.
Okay. So, yes, our next video. We aren't spinning. Deal with it. We are going to get this one going. So, let me know if there is an improvement on the audio. Make sure I did it right, because it should be right now.
Nope.
Hi,
Oh,
folks.
there-
My perspective
there it
here.
There it goes. Okay.
I watched a
Thumbs up,
very
Trevor.
interesting clip by Owen Benjamin where Owen focused on one topic that proves that the heliocentric model is wrong. And it's a simple issue that the path of the Earth around the Sun is an ellipse. So let's listen to Owen now. I want to illustrate some of the points that Owen made and add one or two other issues that are related to this.
Really just put the
I just want to take a moment to relish the irony of the fact that we are reacting to a video about a guy reacting to a video.
Is that why I'm hearing like 3 different voices?
Yeah, it's because Owen
that's
Benjamin's
funny.
talking in the background.
I'm a terrible researcher. What can I say?
I was like, wait, who's talking and who's talking?
Yeah. No, it gets good.
Okay, all right,
Okay.
here we go. Here we go.
nail in the coffin of the heliocentric model. I understand that you go through the stages of grief when you realize that you've been lied to. That you're gonna feel angry, you're gonna bargain, you're gonna all this stuff. I understand. This is the absolute proof. And you never have to say another thing about it. And people get so mad. I get it. You're going through grief. You're mourning grief. Ready? What people forget is that it's not a circle around the sun. Even if it was a circle, it'd still be impossible. But it's an ellipse, which means that it changes speed.
So there's a reason why your watch face is in a
Hang on a minute. Are we in
Yeah.
an elliptical orbit? I know Pluto's elliptical. Is Earth's orbit elliptical?
Yes.
Or is that what he's talking? Is he talking about the rotation of the Earth being somehow elliptical? I don't see how that's possible. Or is he talking about our general
Yeah, they
orbit?
say the solar system, the whole thing works as an ellipse, doesn't it?
No, some of them are perfectly round, and I think others are, or very, very close to perfectly round, and then I think others are elliptical. Like Pluto is an elliptical orbit, which
So
I'm
is the
taking
sun?
elliptical to be kind of shaped like an egg, like not a perfect
Or-
circle.
Earth. I don't know.
Trevor, can you Google? Like I would, but I'm scared to death to mess with these
it's fine.
windows. Can you Google whether or not the Earth's orbit is elliptical?
How do you spell elliptic?
You were about out of luck because I was like, I don't know how to spell elliptical.
Elliptical. E-L-L.
Is everything good, Cody?
Yeah.
I-C-A-L.
So is Earth's orbit elliptical or perfectly round or whatever? And if it is elliptical, how elliptical?
The Earth moves around the Sun in an orbit that is almost, but not quite, circular.
That's what I
An
thought.
ellipse.
So
The orbit is actually an ellipse, a parameter called the eccentricity defines the degree of departure from a circle.
okay, well, how large is the degree of departure? Because that's kind of the important question.
It wouldn't
Point-
matter.
Point
Well, yeah,
zero.
well, because you've got such a large
one
body, it's a large mass.
seven.
So if it's only like a couple degrees off from being a perfect circle, you probably wouldn't feel that if there's going to be some sort of change of speed. Like, I don't know where his point's going, but we wouldn't be able to detect any sort of difference if it's only by a couple degrees that it's not a perfect circle.
I disagree. Go ahead, Trevor. What'd you say?
It says it's 0.0167.
0.016. So it's pretty close to being a perfectly circular orbit, but just not quite.
Then I don't even know why they would make the claim that it's an ellipse. But anyways,
Yeah, like it's practically perfectly round at that small degree. I don't know why they would even bother. But
but let's continue
Yeah,
with the video.
okay.
Just we're getting ahead of ourselves already.
yeah.
a circle because of speed, distance, and time. So there are 24 hours divided into perfectly equal segments. And the speed of the hour hand never changes. It's constant. That's why a watch works. If the speed of the hour hand changed, sped up and slowed down, that means hours would be longer and shorter. Seconds would be longer and shorter. All three elements, distance, speed and time, need to be constant. Now, if we take that watch face and we elongate it...
Okay, I'm sorry. I have to cut this off. That's not true. First of all, we have a leap second every few years, so it's not perfect. Like, we have to add seconds to the calendar as it is. And that's like, it sounds like they're going to sit there and talk about the way that we divide time not being perfect, and that proves something about the flat Earth. But I can tell you, we even acknowledge that the way that we break up time isn't perfect, and we have to correct the clock every so often.
Well, that's if you're going off the Gregorian calendar, isn't it?
Oh, I have no idea on that.
Because there's other calendars.
We've got lots of calendars.
Yeah. Well, I mean, that may be right, but I'm just saying, I don't know where he's getting at, because it's like the premise is, okay, well, these are perfectly divided hours and days. It's like, well, no, they're not. We add leap years, we have leap days, we have leap seconds. We're constantly adjusting the atomic clock as it is, so it's not perfect to start with. Am I making sense? It's like his premise isn't right.
Yeah, I just think there would be a more drastic effect if what they're saying is true.
Well, maybe. I'm just saying this guy's premise, starting out with the idea that things are going to be uniform. Well, A, it's a human measurement, so we're going to make it uniform by our own impulses. B, even by the measurement we have, it's not uniform. We're constantly adjusting the clock as it is. If you go by the world calendar and the atomic clocks and all that.
What do you mean? We're adjusting the clock?
Well, because things aren't perfect. Like, for example, the speed of the Earth is slowing down, or the rotation of the Earth is slowing down. And it's been slowing down consistently for a long period of time. And that's so bad that we have to add like a leap second every few years, because the rotation just slows.
So,
and we're also moving further away from the sun, which alters the clock too. So we already acknowledge the fact that our time scale, like our representation of the clock, isn't perfect.
Why isn't it getting colder if we're moving further away from the sun?
Well, because we're still well within the habitable zone. I mean, it's not like by a lot. It's just noticeable, according to the scientists. Like, we're moving so many inches per year or per 50 years or something like that.
Well, according to the globe, the tilt, isn't the tilt of the Earth why we have seasons?
Yes.
Well, that's that little of a change with the distance from the sun. If we were moving away from the sun, we would all be dead.
No, the habitable zone's quite large. I mean, compared to inches, anyway. I mean, Mars is almost in the habitable zone, just not quite. Like, Mars is like right on the edge of the habitable zone. It's like right on the line.
I mean, you can say that.
Well, I mean, if we're going by the modern theory, the theory is, to address your point, it's like, no, it wouldn't affect anything because we're talking about inches. My point was, this guy's talking about this presupposition about there being a uniform measurement of time, and it's like, well, no, there's a whole bunch of other factors that make our measurements of time not uniform, at least by the 24-hour day calendar anyway. And like, Trevor, weren't you pointing out that there's like other ways that time's been broken up in the past? Like, what'd you say, the Gregorian calendar?
Yeah, we're on the Gregorian calendar, so.
Isn't there like a lunar calendar and other types of calendars?
There's a lunar calendar. There's a
Chinese calendar. There was a Roman calendar, only had 10 months.
Right, so it's just like, it's mankind's breaking up of time, so that's going to be arbitrary, and so of course it's not going to be perfect, so I don't know what this guy's point is.
Don't you think the people who were in charge of putting together how we see time were also kind of hand in hand with the globe people?
The globe people. I don't
The
understand.
people that want us to believe we're on a globe, I guess.
I mean, they could be. I don't know why it matters. Well, I don't know. That's a whole other question. I don't know why it matters whether we're on a globe or not, but I'm just saying our measurements are off anyway, so I don't know what this guy's point is. Or what his point is going to be, I should say, since we haven't gotten that far in the video yet. It's already acknowledged that the clocks aren't perfect.
I don't know. But they adjust it the same every year, so...
Yeah, I mean, maybe that has something to do with it. Like if it's... Maybe the adjustment should be 2 seconds one year, 1 second the next, or something like that. But you could be right. I'm just saying...
I just think
nobody
the
thinks it's
adjustment
perfect
is because
anyhow.
they're hiding something.
I'm sorry?
I would assume the adjustment is because they're hiding something.
Yeah, they're hiding the fact, in my opinion, they're hiding the fact that the dad blame Earth slows down, and when you figure out what the measurement of that, like the way that it slows, once you realize how much it slows down per year, then all of a sudden there's a question buried in that. Okay, if you calculate that back, how far back can you go before it's impossible for life to be on Earth? So if it's slowing down like a mile per hour per year, let's say, and then you rewind the clock 1,000,000 years, well, then all of a sudden the Earth is spinning too fast. And you can't sustain life.
Yep.
That's the problem. The problem is if you actually realize that there's a leap second and you realize you can calculate that back, you've got an instant cap on how old life could possibly be on the planet, and that craps on evolution.
Oh.
That's what they're hiding.
That makes sense.
Yeah, it nukes their radiometric dating theories.
Yeah.
So.
Okay. Well, let's just keep watching this video.
Yep.
Into an ellipse. Well, immediately you see there's a problem. The speed of the hour hand has to change. The distance between the hours and the seconds change. It simply doesn't work. And that is related to what Owen is talking about.
And unlike the evolution lie, where you can just keep adding billions of years, but the billions and billions of years, but it's 1 year. That's a fixed amount of time and a fixed amount of speed. The length of Earth's trajectory around the sun is 940 million kilometers. Thus, the Earth travels about 107,000 kilometers per hour. This means that our planet moves around the sun at an average speed of 30 kilometers per second, or Mach 88. 88 times the speed of sound. So let that sink in. Earth speed, this is the kicker. Earth speed is not constant as the Earth orbits elliptical orbit.
So the same principle with the watch face. There's 12 months in a year. That doesn't change.
You can break that down into any fraction you want. It's still one fixed year.
If the Earth's orbital path was in a circle, your speed and the distance you travel has to be constant. The same as a watch face. Speed, distance, and time are constant in a circle. There's no issues. But if that path is in an ellipse, there are issues.
The way an ellipse works, zoom, zoom, zoom. Okay.
So the issue is, if you are on that ball, and that ball's path is in an ellipse, the time, the months stay the same. Your speed would have to change. Your speed would have to change so that the time matches and the distance matches. Therefore, you are not traveling at a constant speed. And if that's the case, you would feel it and you would know all about it.
When you're going 88 times the speed of sound, and you have to change speeds,
Sorry, hang on, yeah.
you would feel it.
Yeah. I feel like you'd feel it, man. Just
Well, I don't know
straight
why
up.
you would feel it, but again, I'm going to
Because
repeat my previous point. We don't
Centrifugal
think
force,
that the
man.
time, we're always making adjustments to our time anyway. So this entire argument, as far as like, you know, the weirdness of time or whatever, that doesn't work because we're already
What do we
adjusting
adjust
the
for?
calendar constantly.
The leap day?
Well, in the current, well, it doesn't really matter. In the current way of understanding things is to account for the rotation of the Earth. But it could be something else as well
But
that
you
we're
just
not
said it was for
factoring in.
something
My
else.
point is that it's already acknowledged that the speed is not constant, and that our clock face or whatever doesn't, like, it's not consistent anyhow, and we're always having to readjust it. So how could you prove this theory if we're already having to constantly adjust for time anyway?
But we're not constantly adjusting. We adjust for leap day, which is hiding the evolution thing.
Well, that's a reason. I'm just saying they're
Well, I
using
mean-
this as proof. And I'm like, well, you can't use this as proof because we already acknowledge that time is not, like, we're always adjusting our clocks anyhow. So time
why?
is always kind of changing anyhow. It
Why
doesn't
do we
matter.
adjust
It could be
Yes, it
for
does.
the leap date thing. Like, it could be to hide the radiometric dating thing, like what I said. Or it could be to account for the elliptical orbit. It doesn't matter. The point is,
So which one do you think?
I think it's they're slowing down. But I'm saying from their argument perspective, what they're saying is that it cannot be true because you would have to, like, make adjustments to the clock and stuff because we're on an elliptical orbit or whatever. And I'm saying your argument doesn't hold because we already make adjustments for the clock.
Yeah, but the same one every year.
I don't know if we make the same one every year or not. I'm using seconds and measurements of time because it's probably like 1.605342 seconds every 4 years or whatever. And then the next time they change it, it's like 1.22222. You're talking about incremental measurements. I mean, I'm using seconds to basically simplify the point. I don't know what the precise numbers are, but I would imagine it would change. I would imagine that decrease in speed wouldn't be linear.
Well, then I guess we're just going to have to go through the 1.67 or 0.167 elliptical and see what that actually translates to.
It's like a really complicated math question. This is the whole
Yeah.
issue, I'm just saying, I guess what's annoying me is these guys are acting like it's so simple. And it's like, it's really not, though, because you guys are starting out with faulty premises anyway. We changed the clock. We already changed the clock. We already acknowledge that our measurements aren't exactly right. So, yeah, it could be because of the rotation of the Earth slowing. It could be because of an elliptical orbit. It doesn't matter. Point is, we already make adjustments to the clock all the time. So, it's not the same. So, your premise, like, you're starting from a faulty premise, and that's what's derailing the argument. Like, you're starting from one bad presupposition. All right? And then the other thing, now they're getting into this whole other thing where it's like, I don't even know what this point was. He was doing this weird vroom, vroom, vroom thing, and I don't know why he was doing
Because
that.
it has to speed up and slow down.
Yeah, that's what I'm saying. I don't think it does.
You just said you thought it did.
Well, okay, maybe I'm misunderstanding something then, but
You said you thought it slowed down, right? The Earth?
well, the rotation of the Earth, not necessarily the orbit.
On the fat side of the ellipse, it would be slower. It would have to be.
Yes, by a minuscule amount, and maybe that's what's causing the deviation in time. But I'm butchering the way to articulate this. His point was that if it was an elliptical orbit, there would be a deviation in time. He was telling you that there is no deviation in time based on the clocks we use. And I'm saying, yes, there is a deviation of time. So the thing you're asserting is correct, that there is a deviation of time, and we account for that for our clocks, but you're telling people that we assume that there's a perfect 24-hour day all the time, and nobody does. Like, that initial claim that we have perfect 24-hour days all the time is false. He claimed at the beginning of the thing that we have a perfect 24-hour time scale, and we don't, and nobody thinks we do. Nobody thinks we do.
How are you saying that? Who says we don't have 24 hours in a day?
Well, the powers that be, the people in charge of the atomic clock. They're the ones adding these leap seconds and leap years and all these adjustments to the calendar.
I've never seen any of that information, so I can't.
Kent Hovind talks about the leap second.
They just add one every now and again, or
Yeah, they add. I don't remember the precise like how often they do that, but they do it every so often. They'll add a leap second.
Yeah, we'll just have to look into that, I guess.
Yeah. So I mean, it's always been assumed that the time is not. Yeah, they're always
I've always
adjusting the
thought
clock.
there was 24 hours in a day. That's just
Yeah,
me.
and most people do, but that's the whole point with this whole. That's why I brought up the how extreme is the elliptical orbit thing, because you're talking about increments, and most people aren't going to think about those kind of incremental deviations. We say 24 hours because it's just like me saying we change it. We add a second every year. It's not exactly a second, and it's not exactly 24 hours either.
Yeah.
We're just kind of rounding up because we can't, we don't like decibels. So,
Right.
As for the whole, you would feel it spinning thing, which I think is where they're going next. I don't agree, because I think when you get into conversations about centrifugal force, like
Gravity.
if you were to, like spin a bucket of water over your head, I mean, obviously the water stays in the bucket. And to me, it would not be that inconceivable for like a bug or bacteria. Like let's put it like this way. Do you think the bacteria in the water that is stuck to the bucket feel you spinning the water over your head? I would argue no, because they're too small and they're moving in a completely different kind of isolated environment. Is that making sense?
Do bacteria feel?
Well, I'm trying to use
Yeah,
an
I mean,
analogy
you would
that's
have a
simplistic.
downward vector, which you could argue is gravity.
I don't know if you would have a downward vector. I don't think you would feel it because you're in kind of a closed system, as it were, and the whole system itself is being
we're not.
spun, and you're too small to feel any of those kinds of forces anyway.
I find that to be ridiculous.
But it's not a given. Like, why would you why would you like if you're feeling something spin, right? That would mean you're encountering some kind of resistance. But this thing is spinning in the void of space. And so all that force is going to be pulling, if it's space and we're talking about everything being pulled towards a central point, all that force is going to just be pulling you downward. It would be gravity. Like, in order for you to feel the spin, there would have to be some kind of resistance against the globe, I suppose. So there would have to be like a wind current or some kind of friction pushing against the planet itself in order for you to feel the spin. There'd have to be a competing force. If you're talking about a void and something's spinning in a void and everything's getting pulled down anyway, I don't know. I don't think it's a given that you would feel the spin. I mean, I don't know. I'm talking out of my hind end just as much as anybody else is. My point is, this is not assumed. This is not like intuitive or super obvious to me.
Okay.
And Owen Benjamin's talking about, you got to go through denial and all this stuff. It's like, dude, I don't care if the earth is flat or round. I really don't give a crap. It's just you're telling me things. Basically, you're telling me a bunch of premises I don't know if I agree with and I don't think are necessarily givens.
Yeah.
You know what I'm saying?
Yeah.
So, anyway.
Let's just keep going.
Yeah.
Right. So you are going to get some really well-educated people who don't think and reason, and they just regurgitate the nonsense you're taught in the education system. And I'll say, well, if you're on an airplane and you're on a train, you don't feel the speed of the train. Well, that's right. The difference is that the train is not on an ellipse, and the train speed is constant. The earth speed is not constant, so therefore you would feel it. So don't let anybody fool you with this nonsense. If you're on an airplane and that airplane...
So because the Earth's speed is not constant, you would feel the change.
Mm-hmm. I would agree with that.
I'm sorry. I find that, as you said, ridiculous. Especially if you're talking about a very minuscule alteration in the elliptical orbit. Especially when you're dealing with such a large scale object like a planet. Like, that's not...
We've got
one of us
buildings
is right,
that
one of us is wrong, and it's a good debate either way, but this is not intuitive.
We've got buildings that stand hundreds of feet tall. Or hundreds? Yeah. I don't know how tall a skyscraper is.
Yeah, tall buildings, yeah.
And I don't know, I just... I've been thrown off of four-wheelers before.
Uh-huh.
Whenever you turn too sharp.
Yeah.
And there'd be a couple of knocked over buildings, in my opinion, every time we hit that ellipse.
I feel like that would have to be very, very sharp. We're arguing scale, though. That's the whole problem. Is it's like,
What about those rocks? You balance the rocks, like they do in Japan or whatever.
oh, maybe, yeah.
Yeah.
Well, again, I
Balance
repeat the
those.
same thing. We're talking about an object the size of a planet versus, the balance on a rock. And we're talking about an elliptical orbit that's like,
No,
what'd you
no.
say, 0.196 that keeps it from being perfectly circular?
0.167, I think he said.
0.0.
0.0, so yeah.
019 something.
Yeah, so we're talking about a minuscule alteration to a spherical orbit. Like, given the size of the planet, I don't know that the objects on the planet itself are going to feel anything like that. So, for example, if you're going to talk about the example this guy brought up about the trains and the automobiles, like, why do we not feel those alterations? Like the speed or the wind resistance or whatever.
In a train?
Yeah, like as much. Like, why is that?
Windows?
No, the resistance. Like, when you're on a train and you're walking around, you don't feel the wind around the train pushing against you, even though technically speaking, you're, pushing against the wind along with the
Because
train.
you're enclosed. What do you mean?
Exactly. It's a closed system. You are enclosed.
We
It's
don't
a
have
closed
that.
system. Yes, you are. The planet is a closed system. The atmosphere protects you from the forces in space. You are in a closed system,
The
and it's
atmosphere,
going to.
the air
Yes.
that doesn't exist.
Air doesn't exist? What are you talking about?
Yeah, the higher up you get, the less air there is.
Yes, but the lower you get, there is air, and there's air pressure. The same way there'd be air pressure in a plane or in a train. You are in a closed system. It is going to protect you from any sort of resistance that might be in the void of space, which shouldn't have any resistance in the first place. So, therefore, I don't know why you would feel any sort of resistance. A, you're in a closed system. Two, you're in a void.
If the train turned, you would lean.
Yes, you might lean, but that is a very dramatic turn in compared to the size of the like the train is small. Like the scale between you and the train is much smaller than the scale between you and the earth. So you're not going to feel that turn of an entire planet the same way you would feel the turn on a train.
So you don't think if you built a little bitty tiny, so if there was like a colony of ants living on the train, right?
Uh-huh.
And they built a little statue out of those little Japanese rocks that you balance, right?
Yeah,
So
okay.
they built one of those, and the train took a slight turn, just a. You think that little statue thing would fall over?
It would depend on the scale because it's like
No,
it's
it
a
wouldn't.
numbers game. If there's enough force to knock over the rocks will fall. But if there isn't enough force because there's too much of it being spread out over the entire object at large, then the rocks won't fall. Because all that force is energy and it's going somewhere. If you have a larger body, that energy is going to get dissipated. But if the body is smaller, then and the energy is still like concentrated to a certain degree, you're going to feel that. So
the
like if
whole
an
thing is
entire
turning.
planet does a slight turn, there's enough mass to disperse that force that you're not going to feel it. But if a train turns, which is infinitely smaller than a planet, then you're probably going to feel the force of the train turning because that inertia, let's say, it isn't getting dispersed in the same way. And I'm probably
But it is, 'cause
botching that, but that's kind of my guess.
Everything that's involved in the turn is going to experience the force of the turn, no matter how big it is.
Not if that force is dispersed. That's why you
No,
have like the
that's
shape of an
dispersed.
object.
What do you mean? Like we
Well,
got
like-
springs all around us?
Springs.
What are you talking about?
I'm talking
Shock
about
absorbers?
I'm talking about when you have resistance. Basically, the waves, the inertia, gets dispersed around the entire object. If the object is big enough, then those waves and those energy they're going to dissipate like a cloud. It's going to become so weak that you wouldn't notice it.
How are you saying that? Everything in the turn is going to experience the turn.
Yes, it's all going to experience it, but if this force is being dispersed, you're not necessarily going to feel it.
Yeah, I don't understand what you mean by dispersed. I don't know how you disperse
the
centrifugal
inertia,
force.
like the inertia, the waves, the
Right.
friction, the
How do you
energy
disperse
being
it?
like weakened, dissipated, like it's getting spread out.
Would the ant's tiny statue fall over or not?
It depends on the size of the object that the statues are standing on.
A gigantic train.
Yeah, maybe the train is, if it's a little bigger and it's a little smaller, is going to determine whether or not the rocks fall over.
I don't think so.
We need a physicist really bad.
I don't think we do, man.
Well, okay, why not? I mean, you.
Because everything in the turn is going to experience the force of the turn.
We're just going to argue in circles. I mean, look, I'm
Yeah,
saying
we are.
that the bigger the object, the more that force is going to be dispersed. And if it's dispersed enough, you're not going to feel it. It will still happen to you, but you're not going to feel it.
I don't know. Maybe if you're asleep. All right, let's
Yeah,
finish
let's
the
keep
video.
going. All right.
Not finished, but keep going.
And slows down and speeds up, you feel it. It's not the same. The Earth's speed has to fluctuate.
You can do the math on it because the ellipse is fixed and the time is fixed.
If the Earth's orbital path around the Sun is an ellipse, it's just as simple as that.
Guys, this heliocentric model is over. The Earth changes speed going around the sun.
So, speed, distance, and time, they have to be measured and they have to balance out. And if the Earth passes an ellipse, it does not balance. It's wrong. Therefore, the heliocentric model must be wrong. If you are on a ball on an elliptical path, what would your speed be on the surface of that ball? Your speed has to change. Even though that ball's speed is constant, you on that surface of the ball, your speed cannot be constant.
They'll get mad at me. They'll say, "You, sir, how dare you?" I mean, it's so easy to understand. Even an idiot could. LOL. I mean, inertia and vortex, man, that's grief. And then they'll bargain. Well, it could be that it just keep, and then depression. Well, what do we do now? I mean, my whole childhood. Just stop. It's not that big a deal. It's more beautiful that it isn't spinning endlessly around the sun. It's way better.
You see, the green dot is the constant speed. The gray line is your speed.
Can I also say that I challenge the idea that just because the orbit's different, it would change speed in the first place? I don't even know if I agree with that.
If the orbit's different?
Like, if let's say the elliptical orbit was more extreme than it is.
Yeah.
I'm not sure that would make a difference because you're talking
In
about the
feeling
void of
it?
space. Well, no, let's forget the feeling it conversation. Let's just talk about the speed of the Earth changing because of the nature of the orbit. I'm not sure that's true because you're talking about a void. Like, there's no resistance as the Earth is spinning. So why would the nature of the orbit change? Like the speed of the planet change? Like maybe
Because it
our
has
1
to.
hour, maybe our 24-hour day might change. But why would the speed of the orbit change?
That's what he's saying.
It's okay.
It has to change because to match up with time. But they're saying it's an ellipse.
Well, it doesn't have to change to match up with time.
But it does.
Well, again, that goes back to the bad premise that we were talking about. They are assuming that the 24-hour day is fixed. It's not. We adjust it. So
Okay,
that's we've already dealt with that. Like, that premise is wrong. And
Well,
so
you
I'm
say
just
that.
talking.
I still think there's 24 hours in a day.
Go look up a leap second. I am telling you, leap seconds are a thing. They exist, and people adjust the clocks. That there's not a fixed unit of time. A fixed unit of time that's like a perfect representation of time and space doesn't exist. We do the best we can. We generalize. We round up. But that fixed unit of time is not real. We understand that it's real in like the ultimate sense, but as far as our representations of it, it's not perfectly accurate. So I'm making a separate point, regardless of time. Why would the speed of the orbit change if there's no resistance? Just because it's elliptical as opposed to perfectly round.
Because that's how an ellipse works. I mean, like
But
when you
why?
get to the outside of a turn, you speed up.
But on Earth, the reason for that is because you have opposing forces. You have friction, you have wind resistance, you have other physical forces that are acting and pushing against the object. So when you change the direction of that object, the way those forces hit that object change as well. But when you have a void space and the object changes direction, why would that affect the speed?
I don't know, bud.
Because we ran into a comet?
That would do it.
Yeah, we run into comets all the time. Wouldn't that slow us down? Wouldn't that throw off the ellipse a little bit?
But
Possibly
hit
if it was big
comets-
enough, yeah. That's what a lot of these different like theories about how planets came to be. That's how they interact. It's like something hits something else and changes direction, then merges with other objects and all this. There's a whole other mechanic to that, but it doesn't really matter. The point is, if you're talking about a void, speed shouldn't change.
I don't know. I guess that's just like your opinion, man.
Oh my gosh. I am telling you, that is right. Like, you can't have a change in speed in a void when there's no resistance, when there's nothing to change the speed, regardless of the direction it's going in.
Okay.
Perspective.
Wait, are you saying spaceships don't work?
Well, if they have internal thrust that's pushing the ship, they would work.
What are they pushing
Gas.
off of?
What are they pushing off of?
Yeah.
Yeah, the explosion is being directed. You have a central point where it explodes. It directs the force coming from the ship itself, and then it goes up. You could argue
Wait,
maybe
secondary boosters?
from a minuscule level, it's pushing off the gravity being produced by a nearby planet or body.
Oh my god, that's awful horseshit.
I'm making it up. It might be.
Okay.
So okay.
Let's move on.
All right. I just wanted to point that out. But
Right.
okay, the reason I'm pointing it out though is again, I don't care if it's flat or round. I just don't like the arrogance. The arrogance ticks me off.
Gary.
It's like you're grieving. You're grieving. I don't give a flying crap. Don't tell me I'm grieving though. Like, what do I care if the Earth? Like, forgive the pun, but whether the Earth is right or wrong does not. Whether the Earth is flat or round does not change my world in any way, shape, or form. I could not even remotely care. I already assume the government's lying. I already assume scientists are lying. Nothing about my world would change. So why
think
am I
I've heard-
grieving? Why am I
I've
just
heard
so
tons of
destroyed
people.
that the Earth is, whatever shape it is? Why would that
I've
just
heard tons of
collapse
people
my
say what you just
worldview?
said.
Huh?
I've heard tons of people say what you just said, like verbatim.
Yeah, because they're probably mad about some arrogant jackwagon assuming their motives.
No, they all became flat earthers shortly after. I'm just saying.
Look, if the evidence there, I'll become a flat earther. I don't care. It's
Oh.
fine. But I'm telling you right now, everything I've heard so far, I can already challenge. And I'm like, well, I don't know about the flat earth, but I know that's wrong. I don't know about the flat earth, but I know that's wrong. So, I mean, if there's something else I haven't considered, fine. But
The grieving thing is just because like it does produce feelings because it's a belief. So like this is something you've believed for, 20 plus years, however long.
yes, but I don't know if I don't know if my belief and my emotional attachment to my belief is going to override my profound disdain for science and my spiteful wish for them to be wrong. These people have lied, and if the insurance statistics are to be believed, then 17 million people died from that shot, and nobody's going to jail. I want them to be wrong, and anytime they are wrong and they can be proven to be wrong, it makes me happy because I don't like those clowns. So I don't know if my emotional attachment, if I even have one, to the Earth being round or flat, is strong enough to offset my absolute disdain for the scientific community right now.
Sure. Yeah, he's just explaining that he's not trying to single you out for,
Well, I know he just shouldn't be making these emotional claims about people's motives.
No, he's explaining how grief works, and like if you believe something for long enough, you will have emotional attachments to it.
Yeah,
so
that's true. That's true.
If you think you're on a ball, like you go outside and look at the stars with your dad, that's an emotional attachment to that idea,
right?
And you will go through grief because you're going to lose that kind of memory. Right?
Yeah, no, that's fair.
So I mean, that's all he's pointing out.
Okay, I'm just saying, get out of my head, Owen Benjamin. You don't know me.
Emotions aren't real.
It's all a rooster illusion.
Emotions are real. They're from the devil.
All right.
You would slow down, speed up, slow down. If you are on a spinning ball, you would feel it. So speed, distance and time have to be accurate, have to be measured. For you to have a just outcome, for there to be a righteous, just outcome that can be repeated over and over and over, speed, distance and time have to be constant. In other words, an aeroplane traveling from point A to point B, if it travels there and it travels back, the speed, the distance and the time, it's the same. That means the earth is not moving. It's as simple as that. Think about it. What would the aeroplane speed be if that aeroplane was spinning with the earth as the earth spins around the sun? The earth's spin would affect the speed of the aeroplane. That aeroplane would have to spin, would speed up and slow down. And they do not. It means the earth is not spinning. You've been lied to. What they're teaching you isn't righteous, it's not fair, it's not just. So what
do we want to talk about that point, or are we just going to be repeating ourselves if we do?
We can talk about the airplane because I can kind of frame it a little different.
Okay, yeah, go ahead and frame it different.
So like the earth spins, is it clockwise?
I don't know.
I don't know either. Who cares? So if a plane was flying with the spin of the earth, it would be able to go faster, right?
I'll be right back.
Because it's
go ahead
moving
and say
with
yes.
the medium
I don't
that it's
know,
in.
but let's go ahead and say yes.
It'd be moving with the medium that it's in, right?
Yeah, it's just I think that's only taking into account one force. Like the general feeling I'm getting with this is like they're not taking into account the competing forces. Like you've got friction, you've got thrust, you've got other forces at work besides just the rotation of the Earth. Am I misunderstanding something?
Well, no, he's saying if you take a plane from point A to point B, like from New York to Wales,
yeah,
and then you take the plane back the same trip, it's going to be the same amount of time. It just is.
Okay, yeah. If
So why is that?
If it like maintained the same speed, if it went like 400 miles an hour the whole way through, it'd be the same time forward and backwards.
Yeah, the airline procedure, whatever.
Okay.
So it is the same time if you go and look up the flights or whatever. And so why would that be? Because you're either going against the medium that is the atmosphere or you're going with the medium that is the atmosphere.
Okay.
So it should be drastically different times because there'd be more drag. I mean, I don't know if that's what he's saying in the video, but that's how I see it.
It sounded like what he was saying, and then this is just what I heard. It sounded like what he was saying was as the speed of the Earth, well, in this case it's rotation. So now I'm wondering if they're saying if like the rotation of the Earth is at different speeds too, and not just the general orbit. Like, that's a whole other thing. Maybe I missed something, but
Yeah, I don't know.
But if you're talking about the rotation of the Earth, moving at different speeds, I mean, in theory, if you're going 400 miles an hour, you'd be intentionally staying at that speed on purpose. So maybe you'd have to measure things like how much fuel you're burning, what was the wind resistance. Like, I don't know how you would check that.
Getting into them hermeneutics, aren't you?
It's not even close to right. I'm just trying to think, okay, how would you check that? So, because it could be right. Like, it's an interesting question. Does the rotation of the Earth and moving forward or against the rotation of the Earth, does that affect how much fuel will be burned on a jet plane? Because it would stay the same speed no matter what. Because they're going to make it stay the same speed because of a schedule. But how much energy are they using?
Fair question.
So, yeah, I mean, that's an interesting idea. But I would need more, I need to know how much fuel is being burned on a forward and backward trip and how many other factors are at play. And how would you prove that experimentally? Because you've got to make sure wind resistance and thrust and everything is identical in order to test whether or not the plane's actually speeding up or slowing down. Interesting. So, okay. Are you want to move on?
Yeah.
Okay.
What they warp the lines. They try and blur the lines between speed, distance, and time. They give you this Jesuit idiot puppet, Albert Einstein. He's a fraud. And they continue that fraud by saying, they'll post articles in the newspaper by saying, the mystery deepens around the newly detected ripples in space-time. Really?
So you can't do what they do in evolution. Say, well, in 20 billion years, a hurricane can just create a Ferrari. No, you can't just keep adding years. 1 year, one ellipse, change in speed.
Rome. Did Rome conquer the world because they want to make everybody's life better? They wanted to educate everybody. Or did Rome conquer the world because they're looking for slaves? Rome needed slaves. Dumbass slaves. Because otherwise Rome wouldn't have survived. And nothing's changed.
Also need gold and salt and ore and means of trade. Slaves would be one thing among many, but okay. I mean, all right.
The Roman system is still in power. The puppets in the front have changed. That's all. So, if these lying, murdering, thieving thugs created your education system, why on earth would you trust that education system? Why would you be shocked?
I agree with that. Don't trust the education system. These people are vile Satanists. So.
You mean heliocentrists? You mean they worship the sun?
Why would heliocentrists? I'm assuming that means the Earth goes around the sun, right?
Yes.
Okay. I don't know why
So
that would make
you
think that that makes you worship the sun.
Because that's putting Ra, the sun god, at the center of your worldview.
How?
What do you mean?
I
how?
mean, literally.
It's literally
I guess,
putting the sun at the center of your cosmology. When the sun and the moon
I'm not looking
listen,
at the sun for my source of morality.
When the sun and the moon and the stars were set for signs and seasons. So when you put the sun in the middle, you're making something of the sun that God did not mean for it to be.
Or it's an analogy just talking about how the seasons work. I don't. Okay.
Yeah, maybe it doesn't mean anything. Maybe the Bible's a made-up book.
You're the one that doesn't even believe in the entire book of Revelation. Why are you throwing that at me? I'm not the one who disregards like entire books of the Bible. Don't give me that relativistic bull crap.
Oh, man.
We're going to finish the video now.
Okay.
to find out that that education system has been misleading you. Well, when and all along it should have been obvious to you that they're going to lie to you. Bad people don't do good things. Bad people don't do things for your benefit. They do things for their benefit. It's called common sense. So I hope this video makes you stop and think. And I want to end with...
All right. That is the end of it.
That's all I got, man.
Well,
That was fun.
Yeah.
that was fun. We got another 25 minutes. So, we can do another subject, or we can keep having final thoughts. I do think we need to do some closing thoughts on this.
Sure.
Trevor, you were too quiet. What did you think?
I think I'm kind of open-minded about it. You know, going into this, I really, I don't know. It's hard to say.
Yeah. It is. It is hard to say.
I have not seen anything that would make me question the Earth as round model. I'll say that. I'm a little less open-minded than I was before. I'll put it that way.
Oh, you're doubling down.
I might be. Not
Nice.
entirely. I'm not saying this is definitively, like I'm definitively right, because I'm always hesitant to do that as a rule, but
Yeah.
I'm less persuaded that it's plausible than I was. Because here's my thing. I saw a bunch of stuff that basically presented a competing hypothesis, which is fine. But we've talked about before, if you're going to sit there and make a competing hypothesis, you can, but you got to show why one is impossible and the other one is. Now, to the last video's credit, it attempted to do that. It did attempt to show how the round Earth was impossible, which is where you need to start. So it was starting in the right place. The problem is it had a whole bunch of bad premises. The idea that we don't make adjustments to our 24-hour clock. We do. That nukes their entire claim right there, regardless of what even is causing the clock to change. Because regardless of whether it's the leap second or the elliptical orbit, it doesn't really matter. Because if you have a changing clock, you can't prove this idea that the round Earth or the round Earth requires a perfectly spherical orbit. If you've got a changing clock anyway, it still has to. And they're saying that the round Earth exists within that model. Well, then you have to explain how that's impossible. But anyway, the point is, at least methodologically speaking, the video was starting in the right place. You have to start from the idea that, okay, we have to make the round Earth seem stupid, like completely implausible. And then after you've tore down the idea, then you present your competing theory. I think you do. I think you have to expect, because here's the thing, you're dealing with the institution, as it were. You're dealing with the traditional view. And so you have to start, people are going to have that, they're going to default to an authority bias. You know, because the institutions say this, because I am a working person who has a job for a living and has no desire to be on YouTube and argue about this stuff when they barely know what they're talking about. Right. I am going to assume that the authoritative source is right.
Yeah.
And so you are
your position, right?
No, I'm not assuming that they're right because they're the authoritative source. I'm saying everything I've seen is dumb and based on bad presuppositions, so I don't believe it. But
okay. Yeah, I agree. Flat earthers are dumb.
I don't know if they're dumb. I just think that we've been lied to.
Globe earthers are dumb.
Well, I mean, yes, everybody's an idiot. I'm an idiot. You're an idiot. Let's just, there's no end to the stupidity. I mean, that's true. No, I don't think that flat earthers are dumb. I think that we've been lied to, especially so much over the last few years. And I think COVID was a very dramatic example of what happens when you let the institutions just, when you default to the institutions all the time. Yeah, they can become tyrannical. And I think everybody's gotten to this point where, oh, crud, these people are clearly lying. They clearly have their own agenda. What else are they lying about? And I think that's brought people to a place where they're calling into question everything, which they should.
Yeah.
But you shouldn't, challenge a consensus just because it's a consensus. Like, there has to be specific reasons why you don't like it. The round earth theory, and this is something I read. I believe it was in the book Darwin's Day in America. But I read that the whole idea that the church believed that the earth was flat isn't even true. Like, that is propaganda that came out from the French Revolution. When Robespierre and those clowns were trying to trash the church, they came up with these ideas like the church believed the earth was flat. And Columbus challenged it. Like the Jacobins, I don't know if it was the Jacobins. It might have been the Jacobins. But Robespierre and the guys leading the French Revolution, they were the ones pushing this kind of stuff, and they did it to make the church look stupid because they were trying to prop up this cult of reason. So a lot of the stuff that we believe, like Columbus discovering America and everybody believing the earth was flat, that's not even true. That's a result of French propaganda from the 1700s. That was a result of that war. So, and as far as like the earth being round, the Greeks thought it was round. They had those experiments that we were talking about earlier with the sun and the moon, measuring the shadows and guessing the diameter. Regardless of whether that's right or wrong, they thought the earth was round.
Yeah.
That didn't just spring up in the 1950s because of the dad blame communists taking over. People have thought, or the idea that, what am I even trying to say? It's not that people started pushing a round earth recently. It's been thought for forever. And it's a debate back and forth for forever. It's been going on for forever.
I don't know. I've seen...
Well, that's a historical fact. The way the Greeks tested the diameter of the earth, that is a historical fact. You can look that up.
I've seen videos of like 100-year-old people getting interviewed and saying they were taught flat earth as a kid.
Well, sure. I mean, my point is there have been competing ideas since medieval times, since Greek times. Like, there's been a back and forth for forever. This isn't the round earth is not some reactionary thing invented by the communists. People have been debating it for forever.
Well, since Shakespeare, anyway.
Well, still, I mean, that proves the communists had nothing to do with it.
The Globe Theater? All the world's a stage?
I don't know what to make of that. I mean, even if you're right, my point still holds, but yes.
Yeah.
Maybe. Point is, people have thought it for a long time. There's been debates. So it's not intuitive that the earth would be flat. I mean, in my opinion, it would be more... When I was a kid, I didn't need somebody to tell me that the earth was round. I thought, well, the moon's round, sun's round, the earth's got to be round. I mean, we got to be living on a bunch of floating balls and stuff. I mean, that's what I thought when I was 6. I didn't need a school to tell me that.
I don't believe that at all.
Why not?
That you thought the earth was a globe when you were 6 because of what you saw in the sky?
Yes, because the sun and the moon were round. I thought the earth had to be round too.
And you just came up with that all by yourself.
I was a weird 6-year-old.
You were like, man, I must be flying through a vacuum.
No, I did not think of the vacuum of space. That didn't come to me. Anyway, no, what it was I probably was in school, but what it was is I was, the first time I came across the idea of the flat earth theory, I saw this Columbus movie. It was a rented film about Columbus, and there was this bookworm is what they called it. It was some kind of creature that traveled with Columbus, like a Pokemon or something. And it was like they were like making fun of people believing that the earth was flat. And I heard that and I was like, why would anybody think the earth is flat? Moon's round and the sun's round. Why would you assume that it was anything else? But and I was a little kid and I saw that movie, so that's why I remember it. Because I remember I have a vision of this this bookworm thing. There's this scene where it like chews out the corners of the globe, because when they said the Earth was flat in the cartoon, they had a globe kind of thing, but it was a square. They had like a cube instead of a sphere in this globe thing, and then the bookworm came out and chewed all the corners off. But
Oh my goodness.
yeah, I know. It was funny. But I remember seeing that
Hardcore
scene.
propaganda.
Well, yeah, but I saw that and I was thinking, why would anybody think it was flat anyway? I remember having
Yeah,
that
because it
thought.
makes you feel good when you agree with the thing. You're like, oh,
Maybe. I'm just saying I'm not lying. That's when I had that thought, was watching that
Right.
cartoon. So anyway, but I think it's intuitive to assume the Earth is round. I don't know why it would be. It seems like the Earth being flat would be counterintuitive, at least to me.
I don't think so. I think that's your programming talking.
Maybe.
Because I mean, if you just...
But it's kind of pointless to debate motive, because I could just as easily say your disdain for science is talking.
Sure.
I mean, who
But like,
cares?
a culture that doesn't have science, do you think they'll assume we're on a globe?
I don't see why not. Like, I'm sorry, I honestly don't see why not. If you're looking up at the sky and everything in the sky is round, like, is it really inconceivable to think that whatever you're standing on would be round too?
Yeah. That's
Why?
like me sitting in my room and looking at my light fixture in my ceiling and going, "Oh, there's a light bulb. That must be what I'm standing on."
What?
Right.
That doesn't make any sense. I don't think that's a good analogy, but
It's
okay.
a perfect analogy.
No, it isn't. Like, you got different shapes in the room. Like, you've got chairs
Yeah.
and you've got tables and you've got
Trees.
walls and you've got squares. But when you look up in the sky, everything is round.
No, it's not. We talked about this. I mean, maybe the moon is a disc.
Yeah,
but
from your
stars,
perspective,
when you zoom
stars, suns, stars, the sun, the moon, it's all round. Why would you not
Remember-
think what you're standing on is round too? Like, I
Remember
don't
when
see
we
how
talked
that's...
about...
Like, it may not be right, but it's intuitive. Like, I can see somebody assuming that. And so it's kind of silly to, think that it's just all the result of propaganda.
I don't think so. Because you just need like a fundamental worldview, and then you're like, oh yeah, that's obviously the answer. But you have to have that fundamental worldview first. So we talked about the square headlights on the truck a mile away. It looks like a circle.
Yeah.
So why would you assume the stars are circles?
Because nobody is going to assume that a square headlight or that a round... Nobody is going to assume that something they see that is circular is actually square from a distance. I'm talking about not what's correct, but what is intuitive. Is it intuitive to assume that something you're looking at is round? Or is it intuitive to assume that something you're looking at is square when you are seeing that object is round? You could be right about the headlight being square, but that's not intuitive. That's a counterintuitive truth.
Okay.
I'm saying that if everything in the sky is circular, it is intuitive.
But it's not. That's a preconceived
It looks
notion.
circular. From the perspective of somebody looking up at the night sky and seeing stars and the moon and the sun, all those objects look round from your perspective. So if everything you're looking at is round from your perspective, it is intuitive to say that whatever it is you're standing on, since you are surrounded by that object up there, it is intuitive to say, or by those objects up there, it is intuitive to say that you are standing on something that is round too. It is an intuitive assumption. Doesn't mean it's right, but it's intuitive.
Okay.
So my point being, the idea that the Earth is round did not just come up in the last 100 years. It's been around for forever.
So it's intuitive for me to sit in my room and look up at a light bulb and say that's what I'm standing on.
Not if you have other objects in the room.
Where?
Well, let's say you're sitting on
the
something.
ceiling?
Then you've got something shaped like a chair. Let's say you've
Okay,
got
so
a
a
drink
tree.
on a
We'll
nightstand.
call
So
that
you
a
have this
tree.
object called a nightstand.
Okay, we'll call that a house.
What?
I'm trying to put the room outside.
You're trying to put the room outside.
Yeah. So you're saying I'm not on a light bulb because there's a chair in the room, right?
I'm saying that if there's other objects, if there's more than one object,
Okay,
and there's
so
a
if
bunch
you're
of various
outside-
objects inside an area, then it would be silly to assume to pick one object out at random and assume that's the object you're standing on.
Okay, so if I'm outside on the ground and there's a tree next to me and a house next to me, and I look up at the sky at the sun and it's round, and I say that's what I'm standing on.
But it's not
Does
just
that
the
make
sun.
sense?
Yeah, I understand
Huh?
what you're saying, but it's not just the sun. You're talking about the sun and the moon and the stars and the fact that all of that is
Right, but-
completely surrounding you every night.
But what about the trees and all the other stuff that's near me?
Yeah, it's on
Why
the
would I
ground
assume
with
that the
you. There's
light-
a distinction between stuff that's on the ground and stuff that's in the air, and it's above you.
Just like there's a distinction between my chair and my light fixture.
Yes, there is a distinction, but again, we are talking about what is intuitive. Is it really intuitive to say that the earth is flat? Maybe.
Yes.
Okay, maybe. I am just saying that it is also intuitive to say that the earth is round. And so both positions
saying-
have been around for a very long time.
You're arguing against yourself, though.
You don't even know what I'm arguing. I just stated what I'm arguing. I'm saying both positions are intuitive, so they've been around for forever. That's all I'm saying.
Intuitive. You said it's intuitive
Yes.
to look up at the circles in the sky and assume that's what you're standing on, but it's not intuitive for me to do that in my bedroom.
Not when you can like look down and see that you're not standing on it. We're
Right.
talking about scale. Like you assume
okay.
there's an entire giant floating body in space or whatever, or in the firmament or whatever. You assume there's something above you floating, and there's a bunch of stuff floating. Then maybe you're standing on something that's floating too. And maybe that thing that's floating is round. I'm just saying both positions are intuitive.
I don't
And so
think
the
it's intuitive.
debate's been around for forever. And even if this argument doesn't work, there's like historical documents showing that people were proposing the idea that the earth is round.
Well, yeah.
I mean,
But
that's
see,
all
to
I'm
me,
saying.
it's
It's an old argument.
The-
That's my
the-
only point.
The globe Earth side is only intuitive if you have that programming. Like it's not
No,
intuitive.
it's not. And what programming? You're talking about the 1950s programming, right? Or the idea that came up along with scientism, alongside scientism, whenever that began. Well, how can that argument hold if the Greeks were also arguing that the Earth was round?
Well,
What kind of
you could-
programming is that? We're talking about. I'm saying it's intuition because it's been around since the beginning of written history. You're saying that it's only intuitive because of programming, but you're only referring to programming that's been around for about 100 years.
You don't think they rewrite history all the time?
It's a first-hand source. It's hard to imagine that they would be like rewriting history. So they made up a first-hand source of a random Greek guy that's been around and acknowledged since the 1800s. They just came up with that
Aristophanes?
from 100 years.
Yeah. I don't believe Aristophanes was a real person, no.
Okay. You're talking about a lot of moving parts then. So there was this grand... Let's see if I understand it. So there's this grand conspiracy to prove to everyone that the Earth is round. Why?
To make you feel trapped and scared. So they're always like, oh, the comet's going to hit blah, 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 and blah, 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 and we could blow up at any minute, and we're running out of time, and the universe is ever expanding, and you're flying through space, and
They could say all the
It's
same
all-
stuff of a
it's all
flat Earth,
fear.
though.
it's all fear shit.
But they could say the same stuff of a flat Earth, though.
No, they couldn't. What do you mean?
Yeah, they could. Comets hit, and meteors hit before the modern day or whatever. They could just come up with some other reason why those things are slamming onto the planet. They didn't need to come up with the Earth being round. They could say Zeus got mad at us and chucked something at us. I'm confused as to what's so important about why would they, when there's already so much paganism and so much history of different ideas, different ways to scare people. Why would they need to make the Earth round? What's specifically compelling? I do think there is some logic to people covering stuff up to spread certain ideas. Evolution, for example, it is a direct refutation of Paley's natural theology. So Paley came up with the idea of the watchmaker god. Mm-hmm. And that was kind of this idea that was born out of the Enlightenment. It was where we get kind of the concept of natural rights in the same ways there are laws guiding nature, there are laws guiding men, and if we behave in conformity to those laws, society will benefit. It's this kind of beautiful. Yeah, so it's this idea, it's Paley's natural theology. Well, the authoritarians, the feudalists, they couldn't have that. You can't have God creating natural laws that people must abide by, because then you can't have arbitrary rules, that people are making up, for whatever reason. So they needed to get rid of natural theology. They needed to get rid of that foundational explanation for reality. So they invented evolution as a means to justify the various crap that they're doing and to directly refute Paley. So I can see why they did that with evolution, because there's a specific thing they were trying to refute in the past.
Yeah.
I don't know what they're trying to refute with the round Earth.
Well, evolution is you're here by chance, you're an accident, all this kind of stuff, right?
Yeah.
Whereas the Paley's deal is you're special, you have a creator, God loves you, he put you here for a reason, there's laws that he gave you to live by. Mm-hmm. So the people that want to control us are going to want to erase that, obviously. So
yeah.
The globe is all about making you feel afraid and like you're an accident, like you're spinning through space, and you know what I'm saying? It's the same kind of behavior.
I don't know if you could get there with or at least at the very least, it's not as compelling with a round globe. I've never felt particularly
it is, because every piece of note,
the Earth is round. I mean, that's never depressed me.
No, but every piece of news that comes out of NASA or any other space program is frightening.
Mm-hmm.
So it's just a way to manipulate people, in my opinion.
I do agree with you that NASA is frightening. They do intentionally hype things up to scare the crap out of people.
I'm going to mention this every time it comes up. NASA is to deceive in Hebrew.
Why is it significant that it's is there something significant about it being in Hebrew? Is this one of those anti-Jew things, or is this just it just a coincidence that it means lie or whatever?
I don't think it's a coincidence at all. I think it's the revelation of method, or whatever you want to call that.
Revelation of method. So who came up with this term? Who called it NASA?
I don't know. Werner von Braun was the head of the program when they first started, and he was a Nazi.
Well, I don't know who headed it up either, so I don't know. Yeah, he was a Nazi. That's true. I don't know why he would call it lie, though.
Do you know about his gravestone?
Mm-mm. His
gravestone has a Psalm 119. It says, I think that's right. I might be wrong. It says, the firmament declareth the glory of God, or something like that.
Mm.
And no, the firmament declareth God's handiwork. Something like that. I don't know.
Okay.
But I think, honestly, man, I think the NASA program is just the old Cyrus? No, not Cyrus. What's his name? ISIS's big dude. The great hunter.
Dude, I don't know, unfortunately.
What's his name? I'm blanking on it.
Yeah, me too. I couldn't tell you.
But they built this tower, the Tower of Babel, to get through the firmament right, to defeat God and all that.
There's some debate. Yeah, I mean, in the story, yes, essentially, yes.
Right. So to me, NASA is just that program again, and they've been trying to blow holes in the firmament forever. But
So you think they're trying to punch a hole in the firmament?
yeah,
Can we? Maybe this is something for the next video. Can we talk more about this idea of like there not being space and there being a firmament instead? I mean, I feel like the flat Earth conversation versus the firmament conversation are like two different things. Because from my maybe from my limited way of thinking, the Earth could still be around and there be a firmament. You know, I mean, I just don't. I don't know. But
yeah. So from what I understand, I guess my view of the firmament. So there's, I guess it's filled with water that is different. It's like natural, not natural water, source water, I think is what they call it.
okay,
And it's like super hydrophobic. There's no minerals in it. Not hydrophobic. What's the word for it? Like mercury.
oh, I don't know, dude.
It's a superfluid. That's what it is. So the water in the firmament is a superfluid, and it's connected to the great deep and all that.
What's the great deep?
It's in Hebrew cosmology. It's just like the oceans below, where the pillars are that hold the earth up.
Okay.
So the firmament it's cold around the edges, right? Because the sun's light can't reach it because the sun's at the equator.
Okay.
So the firmament would start out there on the edge, and the superfluid freezes at the bottom, right? Okay. So it's kind of what holds it up, I guess. I don't know. But it freezes at the bottom and comes up slowly, and being a superfluid, it has no friction. So the stars, that's what allows the stars to freely keep their rotation, or whatever you want to call it.
So the stars are like in the superfluid?
Yeah.
And so let me see if I understand this. So the idea is that the firmament is basically a layer of water above the atmosphere, and the sun and the moon and the stars, are they floating in this firmament? Like they're just kind of free?
I assume so.
Okay.
They're fixed in their positions. I
Yeah.
don't really know how that works. I'm sure it has something to do with electricity.
I mean, I have no idea.
That's kind of how I see the stars, honestly. Huh?
I hadn't heard that before, so
Oh,
I don't know.
yeah. I kind of see the stars like a big circuit board,
Okay.
and they reflect what's going on down here, but that's just like the energetic version of it.
So what do you think it means by like the signs and the seasons? Like, are we to tell the future with them, or are we gonna?
Well, you want to plant your seeds,
Okay.
spring.
Okay, so the stars are kind of like an almanac of sorts.
Yeah, you could say that.
Okay.
That gets into horoscope stuff, which, but
I wouldn't even
it's
know where
just
to
like-
begin with that.
it's levels of detail. Like the two big luminaries, they tell us. You can get in the Farmer's Almanac and figure that out,
Mm-hmm.
because they tell us signs and seasons for crops and whatever. That's the sun and the moon. And the little ones, the stars, are more energetic, and they just kind of determine what stories take place when.
Okay. Well, it's interesting. I don't know how that all works. I always
neither.
felt like, the three wise men following that specific star to Christ, I always felt like that had some tie-in of what was meant in Genesis 1, but I don't know.
Genesis 1.
When it talks about the stars being fixed in place for the signs and the seasons.
Oh, yeah.
Like, I feel I've always wondered if maybe the wise men understood that in a way that we don't, and that's how they were able to identify the star that led them to Christ.
Sure,
Like
yeah.
there was some kind of, I don't know, way to understand those things that maybe we don't have today or something like that.
There's people that understand it. It's just language. It's a different language.
I wonder what kind of language that would
If
be.
you stare up at the stars for long enough, you're going to start to see patterns and stuff and understand how they correlate to the things that are going on here.
You mean like constellations?
Yeah. Yeah, like in 2000, was that 2020 when there was like a red star and it ate another star. You know what I'm talking about? Like the dragon ate a star. You don't remember that? It's a big deal. It's just a big energy shift.
Is that why this timeline is so weird now?
Yeah, I think so.
Wouldn't surprise me.
I mean, there's like a changing of the guard in the stars, and it has to happen here.
Well, this timeline certainly stinks, and I don't like it. But anyway.
Oh, it's beautiful. It's beautiful.
Well, gentlemen, it's been past 2 hours. I
Nice.
think we ought to wrap it up. So, Trevor,
Yo,
final thoughts.
thank you for watching
Okay.
Indeed. If you
and
watch this,
listening.
I appreciate you.
If you've made it this far, you are a champ.
Yeah. So, Cody, what do you got? You got anything to say?
I don't think so, man. I had a great time.
I
This
did
has been
too.
fun. I like the live stream thing.
Yeah. We got it right the second time around.
Yeah.
So, yeah. All right. Well, I guess we'll call it good then. Guys, thank you so much for watching, and we will see you next time.
Peace, y'all.
Thank you. Bye.